Good morning. It's Wednesday, November 10th, and my brother started working for the pipe doctor on Monday as a helper for Mikey Pipes and to learn the industry. So this video I'm going to try to be a little more explanatory on the boiler that I'll be servicing, which will again be a Weill McLain Ultra 3. I'll be doing a complete teardown and cleaning out the heat exchanger, the trap and everything, making sure it all looks good. And I'll also have to put a drip leg on both the boiler and the water heater's pressure relief valves because Mikey Pipes was there yesterday and he noticed they were missing, so I'll be putting those in too.
Turn right.
Thanks
then
for
turn
watching.
right on.
So here is that Weill McLain Ultra 3. I turned it off and took the cover off. I'm going to close the gas. And here is that relief valve with no drip leg. And this is the one on the water heater. First thing that I'm going to do is make sure that all the wiring looks good, which it does. It all looks like it's in good condition. So now I'm going to take all of the wiring connectors out. That's one thing about this temperature probe in the flue. It comes out really easily. That's also where I take my combustion rating. We have this connection right here, which is screwed in. I have to unscrew that to disconnect that. We have more temperature sensors. This one's the supply. This was the return. That was the exhaust. We have another gas cock here, but I'll be taking off this nut, so this doesn't really serve much of a purpose. Let's see, we have some more wiring up here, and I'll get a screwdriver to remove that one, which is in the Vito. I've been using this Klein multi-tool screwdriver. It's nice and light. You can flip the heads on it really easily. It comes with different heads if you need. And it's insulated in case of water were live. So I'll remove this screw. Pull out this connector and put the screw back, because if I don't, I'll forget about it. Here we have our ignition, so I do have to take off that ground. And not lose that screw. Oh, the screw is staying on, so I'll leave it there so I don't lose it. And then pulling the plug off of that ignition module. There is another screw there to take the ignition module out, and that will be replaced along with the gasket. And when Mike came here for his service call, that was the problem, was this ignition module, which he cleaned up and got working, and now I'll just be replacing it entirely, as well as the gasket that comes with it. So the unit's still really hot, so I'm not gonna take the heat exchanger out just yet. Instead, what I'll be doing is taking my measurements to cut some copper and put those drip legs on. I'll be sweating because I don't have the press tool and I need practice sweating anyway, so I got my cuts made. I'm just going to show you this one solder. on the elbow, and I'll do the rest inside. It's not great, but I'm still trying to get the hang of it. Okay, so I got my drip legs soldered in. Male 3/4 copper adapter, 3/4 elbow, 3/4 pipe going down. Same here. And I know it doesn't look spectacular, but I'm still learning to be good at both brazing and soldering. And I did use Stay Bright 8 with the Stay Clean, because this is what I have for AC really, but it works. One thing I did was I unplugged that smoke detector, even though there's an exhaust fan pulling here. I just wanted to be safe. I didn't want to set off the homeowner's fire alarms, and then the fire department comes out here, because it is wired into a fire alarm system that will call the fire department over here, and then they would be charged, and that would likely end up coming out of mine or Mikey Pipe's pockets. So this is cooled down a good amount. It's still pretty hot, but it's cool enough to work with. I'll follow that torque sequence on these bolts to loosen them and take this off. This is the heat exchanger. What I'll be taking off is the cover plate, and that comes to the inducer fan assembly. And this gas valve right here. This inducer assembly forces air inside with the gas mixture to create the flame, which gets pushed down, the heat gets pushed down, and it is heated, the water is heated in this heat exchanger. This is the exhaust, so the exhaust gas burns up here, comes down around and goes up and out of the house. This here is an air silencer, which helps to keep it quieter. I'll be pulling that off too. And this is the gas piping, which supplies the inducer motor with gas. Here are all our return lines and our supplies. A lot of zones. It's Honeywell, zone relay, Takeo. There's 3, 6, 9, 12, 15, 8, like 30 circulator pumps here. So that's the expansion tank, the pressure reducing valve, more circulators to circulate the water. This is an indirect water heater, so it has a zone coming off the boiler and going to it. But yeah, I'm gonna get started on this now. So here's the inside of that heat exchanger, which really badly needs a cleaning. But after loosening these bolts and taking the heat exchanger cover plate off, this piece just came clean off as soon as I pulled it away. So So I called around at supply houses, figured out what I'd need, and we'll be ordering the part. This is where that's at. And you can see right here, there's charring, which leads me to believe that it was cracked prior to me removing it. You can see that the charring also is there. There's like a lip of charring. So it was likely cracked beforehand. Overall condition of the inside isn't spectacular. I'm going to scrape away at that bottom to make sure that there's no holes forming. It does look good from underneath, but just to be sure, I'm going to be cleaning out all of these fins, which are terribly, terribly dirty. It's shocking how dirty they are. This has clearly not been serviced in a very, very long time, if ever. You can see the amount of buildup on that gasket. It's just a very, very dirty condition. You can see just how dirty I'm getting. I was getting all this buildup. I scrubbed or scraped what I could out of it, vacuumed it out, and then we're probably going to run water through it because this really needs it. So I cleaned it out the best I could. I did rinse it down with water, and I got a lot out of it. Cleaned up the inside a little bit. Cleared out the condensate throughout. Now I'm on to cleaning up this. You can see where that piece snapped. Looks like combustion gases had been coming out there. My guess is that was already cracked, and when somebody put it back on, they couldn't hold it on tight enough, so combustion gases continued to come out. But I'm going to be replacing the gasket and everything on this still, even though a new part will be coming in. Then I'll replace the gaskets on the lower assembly as well. One thing about replacing this gasket is you're tightening this metal piece down onto this piece of glass. So you have to be careful because it does need to be tight in order to create the seal, but you also don't want to crack the glass. And as you tighten it, you can kind of hear the glass moving in there. That new igniter with the new gasket, and that just goes right into this hole and gets held in by these two screws with the ground on them as well, which is very, very like charred up. But with that, now I'm putting back all of the electrical connections. So here is our flow sensor, and our return sensor, which goes right here. We have our supply sensor up top. Here is for the lower, and we have another up here for the blower as well. Now I'll tighten this gas up, and and put back the silencer. Put this ignition plug back. It's good. Attach the gas, open the gas back up, put the flue silencer, or the air intake silencer on. Open up the gas up there, and waiting for it to start up. While I wait, I have the testo booting up, and then I'll take my analysis and the temperature port, where I also put in a new gasket. Finished up with that call. I just tested out the zones, made sure it was getting hot water, cleaned everything up, and then I called the customer to let him know that I had finished, and he gave me some insight on maybe why that part, that crack had happened. He said he tried to reset the unit, and when he did, it made a big boom. I think it's possible that maybe it filled up with gas in there, and when it went to ignite, it ignited a lot, and maybe that had enough force to crack it. Not 100% sure, but it's just a thought that I had. I'm on my way to my next call, which is a pilot going out. I was already there for the pilot going out, and everything appeared to be good to me. But it looks like what I'm going to end up doing is putting an intermittent pilot system on with electronic ignition, because it seems that she's had this problem beforehand for a couple of times with the pilot not staying lit in her basement. Here's that gas valve, which the pilot won't stay lit, but everything seemed to be in good condition. The gas valve is what's suspect. I will be putting in the universal intermittent pilot to solve our issue of the pilot burner going out often. And there we have it. It's running. I'm going to perform combustion analysis and neaten up the wiring, and we'll be good to go. Finished up there. She was very, very happy. I told her that it was going to be fairly expensive to go with the intermittent pilot conversion, and I think when I had said that, she had pictured paying thousands, but it's not close to the thousands, so she went with it, and she's happy that she doesn't have to worry about a pilot staying lit all the time. I did a combustion analysis. Combustion analysis was perfect. Temperature's a tiny bit high, but it's not terribly old, but the combustion analysis was good. There was 0 particle per million, parts per million, carbon monoxide. And now I'm on my way back to the shop to pick up my brother, and on my way back home I'll pick up a water heater for a job. Mikey Pipes just told me to pick up a water heater, so I pick up a water heater. Today was good. I like working on those Weill McLains, although that Weill McLain took me much longer than the others because of how much cleaning I had to do. I couldn't even get the sword in there because of how bad the buildup was, but after just repeatedly chipping away at it, I made sure I could get the sword through all of those pins, going straight in and going in at an angle as well. And it came out pretty clean. It doesn't always look clean, but there's less buildup, and it probably burns a lot cleaner now. I don't know how it burned beforehand, but with that much restriction, I would imagine that it wasn't burning amazingly. And I had never installed an intermittent gas valve before, so that was kind of cool. I was a little nervous, but I realized after Mikey Pipes had explained to me when he installed it previously a few weeks ago, he explained to me how it worked, and just knowing that it still only takes the 2 thermostat wires that are the only That is the only wiring that you need to add into that board when you install it. The other wiring is included and it's all labeled. And it was super simple. Putting in the actual ignition module, I was a little bit confused with. I should have recorded it. It was pretty straightforward. I just wasn't seeing it at like a first glance. But I took a look in the manual and I read through a couple sections. I looked at the picture and I was able to get it together fine. I was considering redoing the pilot gas tubing, but it was fine. The only reason I wanted to redo it was just to make it look really nice, like Mikey Pipes did in that video a while back. But it wasn't necessary. I didn't want the customer to have to pay any more money than she had to. And I didn't want to have to use any more materials than I had to. And that's going to be it. Thanks for watching. Hope this video was somewhat entertaining. I hope it's educational for you, Peter, if you're watching. And that's it.